Hello, everybody, and welcome to a new session of 8 questions in 8 minutes. And today we have with us a very special guest. Today we have Professor George Church. Thank you, and it's a great honor to have you, Professor George, with us today to answer our 8 questions in 8 minutes. Today we're going to focus on longevity. So welcome to our show.
Thank you. It's a pleasure to be here.
So we're going to move to our first question. How do specific dietary patterns influence gene expression related to aging and longevity?
So I think this is widely known, but there are specific interactions between genetics and foods, cholesterol-containing foods like meats, saturated fats, high glycemic index, high sugars, and portion control. You can have a perfect diet, but if you eat too much of it, then that tips the balance towards diabetes and or cardiovascular problems.
Great. So it depends basically on the constitution of the diet to activate certain genes or certain specifics in that gene to activate or to change into a positive or a negative or a healthy or a non-healthy outcome. Let's move to our second question. Can you discuss the role of caloric restriction and fasting on genetic pathway associated with lifespan extension?
Well, the precise molecules, proteins, and enzymes involved in caloric restriction are well understood, at least in animals and human tissues. The moderate fasting typically does not have much impact. So the degree of fasting, I think people underestimate just how intense that has to be, and it's probably not for most people. It's not within the capability of most disciplinary people. Nevertheless, since the genetic pathways are well understood, there's going to be increasing research and drug development for harnessing those pathways without necessarily having to do the fasting itself. All of these things are negotiable in a biochemical sense.
So, I mean, if you look at the history of humans, we've been travelers for thousands and thousands of years. And when we're travelers, what we do is we just fast until we find food to eat. So our genetic constitution and architecture changed into that way of fasting for long periods of time, storing food for or energy from food for long periods of times of fasting until we find food. And in the last 300 years, this changed. So are we here trying to reinvent the wheel in a way, or?
These are subtle effects. I mean, these are not necessarily, and they vary a lot from population to population and individuals within populations. There are some populations that have had so much fasting in their past that when faced with an excess of fatty, salty, sugary foods, they can't resist, and they get diabetes and other problems. But there are other cultures and genetic inheritance that protects them against it. So, for example, some of the Inuit and other native tribes that live on very high fat diets are resistant to it. So, and some that live on high meat are resistant to cholesterol. So it really depends on what your ancestors did. And even under the best circumstances where you have the best combination of your diet with your ancestors' diets, you still are not going to live much longer than the life expectancy of the best life expectancy of the planet.
Lovely. Let's move to our third question. What are the most promising dietary interventions you've observed that have a measurable impact on longevity at the genetic level?
Well, the genetics comes in that there's a just like there's personalized medicine, there's also personalized diets. So a lot of diet recommendations are framed as a one-size-fits-all, and I think when you see that, that's a red flag. It should be personalized, and some of those, there are people that are particularly sensitive or resistant to sugars in general, to specific sugars like lactose, There are people that are intolerant of meats because of particular carbohydrates on the surfaces of the cells of the animals, or have a high hypercholesterolemia, which makes them highly sensitive to meat products, and so forth. And so I think that the coupling of your genome, you should know your genome, you should know what risk factors you have to your diet is, I think, extremely important.
Lovely. That takes us to our fourth question. How does the microbiome influenced by diet interact with our genome to potentially extend lifespans?
I think this is still in the early research stages and fairly speculative. We are learning a great deal about the impact between metabolism and the microbiome. So, for example, my group found a Violinella strain that is found in elite athletes at a time when they're at the kind of peak exercise, and it converts the toxic lactic acid that builds up in our muscles into propionic acid. The exact way that interacts with our genetics and our epigenetics is not fully understood, but it is very interesting that you can get that you get it from your food. You wouldn't normally consider it a diet, although it can be a supplement, just like the probiotics that you get in yogurt. You can take probiotics in pills, pill form as well.
Lovely. That takes us to our fifth question. Can you explain how epigenetics or epigenetic changes induced by diet might influence age-related diseases or overall longevity?
Well, first of all, we want to demystify the word epigenetic. People sometimes pull it out as just like some kind of magic. It is the way in which essentially all of our genetics turns into our body and our development over time from fertilized egg to aging adult. So epigenetics is just the way things work, the way things play out. So diet obviously affects that, and in all the ways we've been talking about so far.
Lovely. And how much is it affected by the psychology in terms of epigenetics?
Well, so there are epigenetic inheritance from generation to generation, and they're forms of extreme stress, post-traumatic stress syndrome and so forth, that can have effects on your, you can have eating disorders, where you either eat too much or too little, or the wrong kind, and anything that causes stress can has some chance of affecting that. It's not necessarily a guarantee.
Yeah. Let's move to our sixth question. In your research, have you identified any particular nutrients or compounds that directly impact the function of genes associated with aging?
Well, when people talk about the function of genes, they're often talking about the expression of those genes and the epigenetics that we've touched upon already. I don't think I have anything special to say beyond what we've already said in the previous Q&A. When you say nutrients or compounds, now compounds includes drugs, and there's a growing list of drugs that are making it into testing for aging per se. Many drugs affect your longevity because they're curing some disease. So that's a little different from affecting natural aging. I don't think there's any FDA-approved drug that really has been developed specifically for natural aging.
And in terms of diet, any particular compound in any of the foods?
Nothing more than what I've already said about, adapting your diet to your particular genetics and probably in general avoiding high cholesterol, high fatty acids, high sugar, and high portions.
That takes us to our seventh question. How do you see the future of personalized nutrition evolving in the context of optimizing gene function for longevity?
So it depends on how far in the future. I think the future is increasingly open to the possibility of genetic modification. So, for example, the COVID vaccines were formulated in an exact formulation of the gene therapy delivered intramuscularly through either viral or non-viral vectors and single genes, DNA or RNA. So I think that can either correct something that's wrong, it's extremely wrong medically relative to the average person, or it could increasingly deal with the average person getting better, being enhanced, just like a vaccine makes you enhanced relative to the average person historically. So, and then that will change your diet. There's a tendency for people not to want to fix their diet, and we need to recognize that from a public health standpoint. If we can give them an alternative where they can still eat bad foods and stay healthy, that inevitably, whether we like it or not, will be something that has a big market share.
So we have the tools to modify the genes, as I understood, and it's just a matter of getting the approvals into getting it into the patients.
Getting it tested, seeing if there's patient-specific, there's any personalized medicine has to go along with it. Many drugs don't require personalization so far, but yes, we need to get FDA and other similar agencies around the world to approve the research findings.
That takes us to our 8th question. What are the key challenges in translating dietary research into practical interventions that can positively affect gene function and lifespan, which actually concludes our discussion for today?
Well, I think some of the main challenges are the temptations that are put in our path by companies that want to serve us. I mean, it's ultimately us that's creating the market that the companies are serving, but nevertheless, the companies advertising and making more and more delicious, and restaurants too, and chefs and so forth. We're all part of the problem. But those are some of the challenges. The others are, the challenges of getting approval for drugs that help us where our willpower fails us.
And do you think education and awareness of the patients also help facilitate that, or it's going to create an awareness of resistance there?
Education is certainly an important part, although very well-educated people continue to do maladaptive things like smoking until it really was, or not using their seatbelts until it was really forced upon them.
Yeah.
So some combination of enlightened government action,
Regulation.
and education. This all needs to come together. Yes.
Brilliant. Professor George, it's been a great pleasure and great honor to have you with us today and share those thoughts with you. Would like to thank you for taking the time and sharing your exceptional knowledge with us. And we would like to thank everybody for being with us on an episode of 8 Questions in 8 Minutes, and see you on our next episode. Thank you.
Thank you.